Hello everyone, in this tutorial we will create a vehicle AI capable of driving on terrain. To achieve this, we will perform a speed trace in a grid pattern to determine the terrain height, which will influence the weight of each grid position. We will also calculate the average slope of the path to adjust the vehicle target speed dynamically. First, we need to disable the motion trajectory collision with the landscape. Go to motion trajectory. Add a new variable. This variable name is floor actor. And reference array, and add this to this actor to ignore of this box collision. Go to vehicle AI. This initialize vehicle AI. Search this motion trajectory component. This initialize vehicle mode, we need to set floor actor. Get floor actor and set this floor actor. We need to compile this motion trajectory first and compile this. Now we disable this floor actor in this box trace collision. We can close this motion trajectory component. Now we need to do the vertical line trace for the line path. So go to event graph. Add a new function. This function name is vertical line trace for location. Add input. This input name is trace location. Vector. Text. Name. And choose array. Add local variables. And this name is hit. Location. Vector. Set hit to false. Get trace location. Set location. For this trace location, get trace location and do the multi-line trace for object. Add a new variable is tracing height. Set it to float. get this tracing height and make vector. This is z. Multiply it by -1. This trace location, we add it with this vector. This is the start and the add location. Next, make array was static. If it hit, we loop through this hit result. Call for each loop with break. Break this hit result. And this hit actor, we get text. It's not empty. Create a branch. And this tag we get the reference. This input is tag. So get this tag. Call for each loop. And we check this tag equal. If it's true, we set hit to true. Set location. And we set this location from hit result. Next, we can connect this to break. After we complete, we can call return out. Add output. This is hit location. Change to vector and single. This is hit boolean, and we return this location. Has hit target. And here we can create a sequence. When everything is complete, we return. This is the vertical line trace for location. And this draw debug we can use for duration to debug it. Go to event graph. We need to refine path with obstacle avoidance function. Open this. And we add another local variable. Name is points. Array of f vector. And set this point, we move this and delete this comment. Set this relax point to this point, and this we don't clear it. Let's move down. And we get these points. Here we create a sequence. We call this loop after this sequence. And this, for each loop, we need to do the vertical line trace for this point. Vertical line trace for location. This array element. And this tag we make array. This is floor. Road actor. And we add this hit location. And we can press C. Select and press C. Vertical trace. Go to event graph. And this function create a road network path. Create a sequence. This relax path, we don't want to relax it too much. So we set this to 2. And relaxation factor is 0.25. And this sequence we call for each loop. This array path to final target, get path to final target, and we do the vertical line trace for location and check for the actor that have this tag. We check for floor and road actor. When we get this hit location, get path to final target, set array element. The index is the array index, and this is the hit location, and size to fit is true. After that, we return, and we need to set this tracing height. Let's compile it first. Set tracing height to 500. Let's do the test and click on this location. We do this line trace and move this path to this hit location. But we have some problem because when it didn't hit, this line will float. Now we create another function is line trace for location fallback input vector trace location boolean sorry float preview hit z. This is the previous z location and create a sequence. We do the vertical line trace for location and this trace location tag make array floor and route actor. Next we create a branch, add local variable is hit location. This is single set hit location. Then is hit z float break this hit location and only use the value. Add another variable as hit target. This is boolean and set this as hit target. And if this vertical line trace didn't hit the target floor or route actor, we need to do another vertical line trace with the previous hit the value. So this trace location, let's break this vector and make vector x, y, and this is the and connect this to trace location. And we set this hit location. And hit Z. Break this hit location. And has hit target. Next we return node output hit location, hit Z, and out hit target, and name this out hit location out hit Z. And this is vector, float, and boolean. Like this. Compile, go to event graph. We need to Use this line trace for location fallback. Go to refine path with obstacle avoidance. We don't use this vertical line trace. Delete this. Add local variable is real hit Z to store the previous hit landscape or road actor location. Let's set this. And get brief hit Z. And add this hit location to these adjust points. Go to create road network path function. Add local variable is line trace complete. Set it to boolean. Reset this to true first. And delete this. Use line trace for location fallback. Is trace location variable real hit Z. This is float that real hit Z. And check if it's true. We set this out hit location. If it false, we set line trace complete to false. We need to return the output is complete. And this is line trace complete. And go to event graph. When we create road network path, create a branch. If it's true, we spawn default spline, and if it false, we reach final target. So we don't spawn this default spline. The same with this. Create road network path. Create a branch. Reach final target if it falls. Complete. Compile. Let's playtest if this function is working. So now, if it didn't hit the landscape, it will tracing use the previous hit location high. Search for a function add path location to target, and this we use the vehicle target location Z high. So delete this. We just use the vehicle actor location. We can search for debug grid and enable this debug. Save. Let's add a box here. This scope and scale it up to 10. 10. This set to 5. 5. Let's play test. We can see that this grid tracing is not working correctly for this type of terrain. We can close this debug for multi-line trace. Add a new function. This function name is vertical line trace for grid. Create a sequence. Add local variable is location. Vector. That is location. The trace location we need input. Into vector and trace location. Add local variable. Name is floor hit. And another one is road hit. Get trace location. Get trace location. Add with this trace high. We make vector. This is the value. Add it. And another one is the reverse is multiply with -1. Then call multi-line trace for objects. Set to start and add location. This object type we need to make array was static. We add a branch. Out hit for each loop with break. This array element break hit result. Hit actor we get reference, get tag, and this tag we get reference. The first index is 0 and check if it is not empty. Create a branch. and we if it equal to floor, get another reference. If it equal to road actor, this text. Create a branch. If it equal to floor, we need to set floor hit to true. If it false, we check the road actor. If it equal to road actor, we set road hit to true. And floor hit, we set location. And this hit location. The same with road hit. This hit location. We connect to this brake. This road hit, we don't need to set this location because we want to check the landscape, not the road. And when it complete, we return the sequence next to this return. A variable. This is vector hit floor location. In this return node, we get location and we return this hit floor has floor hit has road hit. Get road hit, compile, go to event graph and go to this peer trace grid. We add in this set grid cell value. We add local variable. This variable name is grid location. Vector road hit boolean and floor hit boolean. We need to do the vertical trace for the grid location. So create a sequence. Vertical line trace for grid. Get row location. And set this grid location. Floor hit, we set to floor hit. And road hit. Get obstacle location grid, and we add to this array the grid location. This get grid cell value from row. Open it. Delete this high index and width index. Add variable is floor location. And another input is row location. This is Boolean and Boolean. Local variable. Add a new variable is hit location. Vector and hit. Change to Boolean. And this speed trace by channel. We need to set this hit. And we don't need to add this obstacle local location grid because we already add it in the line trace. We don't need to do this line trace. Let's close this, delete all of this. Get hit. Get is floor location. Not Boolean. Or we add a branch. If it's true, we set local grid value. Set it to 2. Set it to 2 if it is the obstacle or unable to detect the floor. We add a branch. Is road location. If it's true, we set to 0. And if it's false, we set to 1. And we return this local grid value. File. We have an error in this function. We need to disconnect this. Right? And we need to set this road hit and floor hit. And grid location. Change this grid location. Compile again. Find the function grid point to location. This is the pure function that convert this grid point to the world location. So we can delete all of this. Get grid width, multiply x, and add with y. Get obstacle location grid. Get a reference. And we return the value half. Go to this set grid cell value. This draw the box sphere with point. Open it. And we don't need this. Delete this. This center location, we can use grid point to location. And this is center location. And this debug grid, if it didn't hit the floor, we don't need to draw the debug sphere. So get floor hit. And Boolean. Fail. Let's play test. And drive it here. And the sphere trace grid is working correctly. Now we need the grid cell value to influence the weight of the grid. So add a new function. This function name is get grid cell value from terrain. Grid location. Add input value. This is float. Break this grid location. Get grid center location. Break vector. And we subtract this z. Call absolute. Map range clamp from 0 to 200, 0 to 0.5. And add local variable is influence value. Set it to float. And set this influence value. Get influence value add it with the value from the input. Clamp, load, min is 0 and copy this value. If it equal to 2, when it is obstacle location, we select float is 2 and 1.8. This is make. Then we return. The output is grid value. Connect to this grid value. Go to event graph, address grid, set grid value. After we get grid set value near obstacle, we call get grid value from terrain. And move this. And set this grid value. Let's play. Now the height of the landscape will influence the weight of the grid cell value. Go to event graph. And this stop vehicle, we can reset the false spline. Close all of this. Go to BP spline road. In event graph, this for loop, we need to adjust the spline road because now the spline road clip into the landscape. So we want this spline road to have the rotation the same as the landscape, and it will not go through under the landscape. Add index, set integer, and this is index. We can delete this. We will create a new function to store this logic. So add a new function. This function name is get location tangent for spline mesh. Input integer index. We can copy all this function and paste it in this. And we can delete this. We add a sequence. disconnect this, and move this down. We copy this, and another one is local, and we get location at distance along spline, and this is world, and delete this function and copy this, copy this, this is section length, and this is the index. Get index, connect this index, add with 1, the next index, create a sequence, add variable. This variable is where start post, vector, local start post, where start tangent, local start tangent, where add post, local add post, where add tangent, local add tangent. And next we set where start post, local start post, where start tangent, and this is local start tangent. Like this, and this. Do the same with where add post, local add post, where add tangent, and local add tangent. Like this sequence. And connect this. We compile. Next we add new function. This function name is vertical line trace for normal. We want to get the normal that hit the landscape. Add input. This is trace location, vector, tag, name, and array, sequence, It is similar to this function vertical line trace for location. Just this function we get the normal instead. So add variable hit boolean normal vector set hit to false, set this normal z is 1, get trace location set to location and another variable is location. Get trace location, add make vector z 500 multiply with -1. We want to start at 500 and -500. Call multi line trace for object. This is start, add, make array, was static. And when this hit, we do the for each loop with break. If it true, break this hit result. This hit actor get tag. It's not empty. Create a branch. And we get the row index of this tag. Get tag. You need to get tag from this input. So be careful with this. For each loop, and check if it equals. Create a branch. If it's true, we set hit to true. Set normal. This is the normal. And set the location. And this location. When it hit, we break this loop. We return when this loop is complete. Output hit location Z, single, float, hit normal, vector, has hit target, boolean. Get location and break this vector. This is Z. hit normal, and hit as hit target. When this complete, we return in from the sequence. So if it didn't hit the landscape or road actor, it will return this normal. Compile. Create a new function. This function is line trace for normal fallback. Sequence call vertical line trace for normal. And this input is trace location vector preview hit Z float. Make tag array. This is floor and road actor and trace location. As hit target, create a branch. Create local variable is hit normal and hit Z float. If it's true, we set this hit normal and hit Z. And if it false, we do another vertical line trace for normal. This trace location, make vector X, Y, and use this Z, the previous hit Z. Copy this tag, the same tag. And we set hit normal and hit location Z. The sequence we return. And output is out hit normal vector out hit Z. This is float. Get hit normal and hit Z. We can compare. Next, we get this index and call get location tangent for spline mesh. This line trace for normal fallback. Let's add variable. Its variable name is preview start hit Z and preview at hit Z. Get var start post. Set this preview start hit Z. Add variable is hit start normal. vector hit at normal. Set this. Do the same for at position. Get well at post and set real at hit Z and hit at normal. After that, we set start and end location. Get the start tangent. And this is start tangent, and use the add tangent as the add tangent. Local start post and local add post. Add hit start normal, hit add normal. We multiply by 10. We want to move this location up a little bit. And this multiply by 10. Need to start post and add post. We can save all and we play test a little bit. And this Spline road still working. Add a new function. This function name is calculate roll angle. Tangent normal and vector. Make vector z is 1, and this tangent we normalize it to get the unit vector and multiply, copy this vector z dot product and we can subtract this up vector with this, then normalize. Add another local variable is projected up. Set this to projected up. Get projected up dot product with normal input. Get normal. Equals degree. Select float. And multiply this with -1. copy this get variable and call cross product get tangent normalize dot product if it less than 0. We select the float and return. And this return value is the roll angle of the spline mesh component. So we call calculate roll angle get local start tangent and hit start normal. Another one is local add tangent and hit add normal. Get mesh component set start roll decrease, and this is the start roll degree. Next is set add roll decrease. Compile and save. Play test. Now our spline have the correct rotation as the landscape. Because we have the correct roll degree when we do the line trace with the landscape. Next, we need to calculate the slope of the path of the vehicle to set the correct target speed for the vehicle. Go to vehicle AI component, add function. This function name is calculate sample point slope. Add input sample points, vector array. Get length, subtract with 1. For loop, this is the add index. The start index is 1. And add local variable is index integer. That is index. Get sample points. Get this reference from sample point. And this index, we subtract it with 1 to get the previous index. and then we break with the dz, we subtract with dz the previous point and go with the 2D. We get distance 2D of these 2 points. A variable delta y, delta x, and this is float and float. Delta y for the z different, and delta x for the distance in 2D. Delta x greater than 0. We add a branch. And get delta y divided by delta x. Add variable. Local variable is slope. And set the slope. If it's true, add variable is total slope. Add another variable is slope count, integer, and we set total slope, get total slope, add with the slope, and get slope count. We increase integer, and we need to return when it's complete. Get slope count greater than 0. Create a branch. If it's true, we get output float average slope. This is single. Get total slope divided by slope count. And the return is 0 if it false. Create a new function. This function name is calculate target speed based on slope. Add input, sample points, vector, array. Take the length of the sample points is less than 2. If it's true, we return. Get mean speed. Add output. Output name is target speed. float. If it falls, create a sequence. Calculate target speed based on slope and get sample points. Sorry. Calculate sample point slope. Get sample points. This average slope, we need to add a local variable. Average slope. Variable type is float. Set average slope. Check if it's greater than 0 and create a branch. If it's true, add another variable. Up slope sensitivity. Add another variable is down slope sensitivity. And add variable slope sensitivity. Then we set the slope sensitivity. If it's true, get up slope. If it false, set this down slope sensitivity. After we get this average slope, we need to map this slope to target speed. Absolute multiply with slope sensitivity. Then claim float 0 to 1. Subtract 1, subtract with this value. Multiply with max speed. Claim float min and max. Get min speed. And this max speed. Then call return. And we return this as target speed. Map to speed. This up slope sensitivity, we set it to 1.2 and down slope sensitivity 1.5. And compile, save this. Go to function. This calculate target speed from curvature. We can disconnect this. And create a sequence. Next, we calculate this target speed from curvature. Like this. We can collapse this as a function. Collapse to function. Name this to calculate target speed based on curvature. And move this. Open. Add input. We need vector array. Name it sample points. Connect to this. And we return. This is the target speed. And compile and delete the sample point and get sample point from input. Get sample point. This local variable. We add a new variable is curve speed. And another one is slope speed. We set this to target speed. And we need to calculate target speed based on slope. Copy these sample points and set the slope speed. Next, we add another sequence. Get curve speed and slope speed on min float natural speed. File and save. Go to event graph and this calculate target speed from curvature. We can rename this function. Calculate target speed from curvature. Rename it to calculate target speed. We can move all these functions to a new category. This category name is terrain handling. And move all of these to terrain handling category. And this tracing height variable, we can move it to move to target category. Compile and save. Let's play test. we can set this location. At this location, the vehicle is avoiding the obstacle. This is the end of our tutorial. If you like this tutorial, please hit like and please subscribe to my YouTube channel. Thank you very much for my patrons member who are supporting me. Your support really means a lot to me. Thank you very much for watching. See you in the next tutorial.